Density can be thought of as the amount of stuff in a ratio with the amount of space it occupies, or more formally, the ratio of mass to volume. In this problem, we're given a hemispherical tank filled with water, and the tank has a diameter of 14 feet. So we're looking at a massive bowl, and this is 14 feet wide. We're probably going to need the radius, if memory serves me correctly. The formula is going to involve the radius, which in this case would be 7 feet. Okay? If water weighs 62.4 pounds per cubic foot, and what you want to note there is that's a measure of density. It's a measure of weight or mass, pounds, per cubic foot, which is a measure of volume. So mass per volume is density. So this amount right here, let's put that in orange, that's going to be our density value. Our actual question is, what is the total weight of the water in the tank? So what we're looking for is the mass. So our goal is to find the mass. We're going to need this. We're given this. This is 62.4. In order to answer this question, we're going to need the volume. Kind of a no-brainer given the kind of questions that you're probably working on right now. So we have a volume formula here, so let's go ahead and use it to find the volume, because that's going to be needed to then find the mass to actually answer the question. So the volume formula is 4/3 pi r cubed. So 4/3 pi times the radius cubed. Let's calculate that. Wait for Desmos. All right. 4/3 pi radius to the third power is 1436.755. 1436.755. So our volume is that number. And that is cubic feet, because it is a volume measurement measured in feet. Okay, so now we know this number as well. So let's plug everything in. The density is 62.4. The mass is what our desired quantity is. Don't know that. But we do know that the volume, thanks to a little bit of calculation, is 1436.755. So to solve for mass, one simply needs to multiply both sides by 1436. And as usual, I did not plan my real estate out properly on the page. Well, someday I'll learn. So multiply by this number on both sides. So much faster with paper, but coronavirus. Okay, so the mass is the product of the density and the volume. So we take this number and multiply it by our density. Excuse me. And we get 89,653.5. 89,000, 653.5. So to the nearest pound, this would be the same as my weight during the quarantine. Pounds. And there we go. Okay, moving on to a different kind of problem. I've forgotten a number here in my modification of this problem. Let's call this 2.3. Okay, sorry about that. A shipping container in the shape of a right rectangular prism. Let's pause right there, draw a little thing here. Right rectangular prism. Basically a fancy name for a box. With a length of 12 feet, a width of 8 feet, and a height of 9 feet. Okay. The container is completely filled with contents that weigh on average 2.3 pounds per cubic feet. Stop. That is a measure of density. 2.3 pounds per cubic foot is a density measurement. Again, weight, mass per volume. What is the weight of the contents in the container of the nearest pound? So this time we are looking for, I don't know if my color coding matches with last time, but bear with it. We're looking for the mass. That is our missing quantity here. We need to find this. We're given the density, that's 2.3, so no issue there. Once again, the volume is missing, so let's pause and find the volume. So ultimately we need the mass, but let's find the volume. The volume of a rectangular prism is length times width times height, which is 9 times 8 times 12. I don't know if I got the exact numbers paired up correctly, but order does not matter when you multiply, so I don't really care. 9 times 8 times 12, 9 times 8 times 12 is 864. So the volume of the container is 864 cubic feet. We're multiplying 3 feet measurements and thus cubic feet. Okay, so we have our volume. So the volume is 864. We still need the mass. And the density is 2.3. So just like before, multiply both sides by 864, the volume, to get the mass. So take this number times 2.3 gives us 1987.2. So the nearest pound, this would weigh 1,987